All right, guys. Welcome to the last week of CP Chemistry for the 2019-20 school year. Sorry it's ending this way with a pandemic and virtual instruction, but we've made the best of it. That said, you've got a couple of days left this week, and then an assessment next week, a lab assessment, which I'll talk about later this week. And then we're going to talk a little bit about real world applications of chemistry to round out the school year. So let's do today's warm up together. Here's a problem with magnesium. And magnesium reacts with hydrogen nitrate solution to make hydrogen gas and magnesium nitrate solution. The following data is collected. And I'm going to go ahead and change the magnesium nitrate mass because I did this on Schoology already. So it's just a little bit less. There we go. All right, so step 1 per your stoichiometry notes is to write the complete balanced chemical equation for this reaction. So we're going to go ahead and start with our magnesium, which is a metal, it's solid, and that reacts with hydrogen nitrate. Hydrogen's a +1, nitrate's a -1, and that's aqueous. Reacts to make hydrogen gas, which is diatomic, and magnesium nitrate. Magnesium's a +2 ion, nitrate's a -1, and there you go. Now, before we do anything else, we want to make sure that this is a complete balanced chemical equation. And so we're going to go ahead and balance it. In this particular equation, there's an imbalance between hydrogen and nitrate and the reactants and products, which I took care of by just adding a 2 as a coefficient in front of hydrogen nitrate. So that's step 1. Step 2 says if all the magnesium reacts and there is excess hydrogen nitrate, how much hydrogen should be produced? So this is our unknown, the amount of hydrogen that should be produced. The known is the amount of magnesium that reacts. So in this particular reaction, we know that we have 40 grams and that all of it is reacting. So we're going to go ahead and start setting up this problem with the 40 grams of magnesium. Now, in order to relate magnesium to hydrogen gas, we've got to relate in like quantities, right? And so we know that coefficients in a chemical equation represent particles, and that particles in 1 mole are constant, right? So what we need to do is we need to convert from mass in grams to moles in grams before we can relate moles of magnesium to moles of hydrogen gas. Okay? So in order to do that, you just need your periodic table. Find the molar mass of magnesium, which is just a single element, so that's pretty easy. And then we're going to go ahead and divide 40 grams of magnesium by 24.31 grams. The grams cancel. And we get 1.65 moles of magnesium. But we're not wanting to know how many moles of magnesium react. We want to know how many moles of hydrogen gas are produced. So then we're going to go ahead and convert moles of magnesium, that 1.65, to moles of hydrogen gas. And that's where we use our coefficients, right? So for every 1 mole of magnesium, we yield 1 mole of hydrogen gas. So 1 mole of magnesium, 1 mole of hydrogen, which makes this an easy math problem because you're going to yield the same amount of moles of hydrogen gas as you did moles of magnesium to start. Now, we're not wanting to know how many moles of hydrogen gas are produced, we want to know the mass of the gas. So we're going to go ahead and take 1.65 moles of hydrogen, and we're going to convert moles here into mass using the molar mass of hydrogen, which is 1.01 times 2, and we get 3.33 grams of hydrogen gas produced, which is awesome because that's what we were asked to solve for up here. Okay, now this would be your theoretical yield. In other words, if all things went perfectly and there was no experimental error at all, then we would expect to produce 3.33 grams of hydrogen gas. But as you guys know, there can be a lot of experimental error. Perhaps when you added the magnesium to the hydrogen nitrate, you didn't wait for it to fully react, or there was some sort of strange measurement with mass, or you forgot to tare your balance. So there's a lot of experimental error that can lead to a different result. So based on the data above, this question asks how many grams of hydrogen was actually produced. Okay, so let's go back to our data table. That would be the experimental. And in order to determine that, I'm going to go ahead and erase this. What I need to know is what the combined mass of my reactants were, and then what the mass of the products are. Because where's the gas going to go? This is an open system, so the gas, which is hydrogen, will escape, right? Which explains why the mass is less after the experiment, right? Open system, particles leave the system, therefore decrease in number of particles, right? So I'm going to go ahead and take the combined mass of magnesium and hydrogen nitrate, which is 340 grams, and subtract from that the 337.15 grams to find the actual mass of the gas. And I get 2.85 grams of hydrogen. So that's a little bit less than our theoretical. Again, this would be the experimental. All right, and I just realized that I left my calculator upstairs, so I'm going to go ahead and set this last part up, and then you guys can solve it. It's not too difficult. So to calculate percent yield, which is a measure of how precise your data are, you're going to take your theoretical mass, and you're going to subtract your experimental mass. Then you're going to divide that by theoretical, and you're going to multiply by 100. So our theoretical was 3.33 grams of hydrogen, and our experimental was the 2.85 grams of hydrogen. And then we're going to divide that by 3.33 grams and multiply it by 100, and we're going to get a percent. In this case, the percent is going to be positive, meaning that your experimental error was in the positive, meaning your final answer was just a little bit less than what was expected for your outcome. Hopefully this makes sense. I'm going to do another one of these for a nickel and silver single replacement reaction this Friday. In the meantime, you guys are working on your stoichiometry worksheet all week, so make sure to check into office hours if you have any questions about that. All right, peace, love, and chemical reactions. Bye.